Okay. So how high level overview ရကျွန်တော်တို့ပြောခဲ့ပြီးသွားပြီကျွန်တော် discuss လုပ်ပြီးသွားပြီပြီးနောက်တစ်ခုကကျွန်တော် project to product ဆိုတဲ့ဟာကိုလည်းကျွန်တော် discuss လုပ်ပြီးသွားပြီ right အကုန်လုံးကျွန်တော် video teaching လို့ဆိုရှင်ကြည့်ပြီးတော့ပြီးထင်ပါတယ် then let's start from this a business logic converts into code ဟုတ်ပြီအဲ့ဒီဟာကိုကျွန်တော်ဘယ်လိုမျိုးကြည့်မလဲအဓိကကျွန်တော်တို့ run နေတာပါလဲဆိုရင်ကျွန်တော်တို့လုပ်ပါဒီပါလဲဆိုရင်ကျွန်တော်က Kubernetes cluster ပေါ်မှာကျွန်တော်ကဒီ application တွေ run မှာ right ဒီမှာ microservices တွေ run မှာ so right what is microservices right microservices ကပါလဲဆိုရင်ဒီ business logic တွေကိုသူက programming language အောင်းစုံနဲ့ရေးထားပြီးတော့အဲ့ code တွေနဲ့သူကရေးထားတာ so example let's look at it အဲ့တော့အဲ့ business logic အဲ့ code တွေဒီဘယ်မှာရှိမလဲဆိုလို့ရှိရင် they will store in Git repository မှာရှိတယ်ဒီမှာဆိုလို့ရှိရင်ဒါဆိုရင်ဒါ microservices ကျွန်တော်ရဲ့ application ကျွန်တော်ရဲ့ဒီ application ဒီပါလဲဆိုရင် online shopping လုပ်တဲ့ business right ဒါ product right product and services right ဒီမှာဆိုရင်ကျွန်တော်တို့က microservice လေးတွေအများကြီးရှိတယ်ဟိုနော်ဒီ website တစ်ခုမှာ okay ဒီ microservices ကဘာတွေပါလဲ right ဒီ business logic တွေကိုသူက code အနေနဲ့သူကဒီထဲမှာ Git မှာ store လုပ်ထားတယ် so အဲ့တော့ကျွန်တော်တို့ဒီ layer ကိုကြည့်မယ် right let's start from this layer okay business logic converts into code အဲ့တော့ဒီထဲမှာကြည့်မယ်ဆိုလို့ရှိရင်ဒါကျွန်တော်တို့ရဲ့ microservices sample right Google ရဲ့ microservices sample အဲ့တော့အဲ့ microservices ရဲ့ architecture ကဘယ်လိုရှိလဲဆိုရင်ဒီမှာကြည့်တွေ့လားmicroservice found 12ခုရှိတယ် right ဘာလို့ microservices ဆိုရင်ပထမဆုံး front end ဆိုရင်လည်းကျွန်တော်ရဲ့ user interface website right အဲ့ဒီဟာကိုဗာနဲ့ရေးထားတယ်ဆိုလို့ရှိရင် you can write using HTML JavaScript or ဒါမှမဟုတ်လို့ရှိရင် like a React or Node.js သက်ဆိုင်ရဲ့ developer တွေက programming language အမျိုးမျိုးနဲ့သူကရေးထားတယ် right အခုလက်ရှိတော့ကျွန်တော်ရဲ့ဒီ example မှာဆိုလို့ရှိရင် that is written in Go programming language နဲ့ရေးထားတယ် front end ဆိုတဲ့ microservice ဒီ front end လေးရှိုံနဲ့ပြီးတာမဟုတ်ဘူး right ဒီ microservices တစ်ခုနဲ့တစ်ခုကကျွန်တော်တို့ we will communicate each other right ကျွန်တော်ကပစ္စည်းတစ်ခုဝင်လိုက်တယ် then ဘာလို့လဲဆို user က website ကိုဖွင့်လိုက်တယ် and then they will buy they will click front end then they will check out for example right what do we do so example ကျွန်တော် I click this ဒါဆိုရင်ဘာဖြစ်သွားလဲဆိုရင်ကျွန်တော်ကပထမဆုံး front end ကိုကျွန်တော်က access လုပ်တယ် front end ကနေမှကျွန်တော်ဒီကျွန်တော်ဒီ sunglass ဆိုတဲ့ဟာကို access လုပ်တယ်အဲ့မှာကျွန်တော် add card လုပ်လိုက်တာနဲ့ that it will call another microservice called card microservice and then when I click order that it will call order microservices and after that and then it will send we got invoice ပါညာ right ဒါလည်း sample ဖြစ်တဲ့အတွက် it's only a few microservices တစ်ခုပဲရှိတာ right but in the reality to get real you think about it is thousands of microservices in one application right insurance or taxi booking application or blah 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 blah, blah there are so many okay hope you know so that microservices အဲ့တော့ဒီမှာကြည့်မယ်ဆိုလို့ရှိရင် now this layer business logic converts into code အဲ့တော့ကျွန်တော်ရဲ့ business logic front end ဆိုတဲ့ business logic is convert into code using Go programming language ဘာလို့လဲဆိုလို့ရှိရင် okay science ကလုပ်လို့တယ်ဘာညာပြီးကွာI can imagine then we will call other microservices like a payment microservices email microservices the front end called checkout microservices user က internet ပြင်မဲ့မှာရှိမယ်ကိုယ့်ရဲ့ဒီ application ကကိုယ့်ရဲ့ Kubernetes cluster ပေါ်မှာ run နေမယ် right or cloud provider ပေါ်မှာ run နေမယ် cloud provider Kubernetes cluster ပေါ် run မယ် and then the moment you access front end the child microservices they will start to access it the two microservices all communicate each other so card microservices so card microservices ကဘာလို့လဲရှင်းရှင်းလေး right it's written in C# doesn't matter တိုက်တဲ့ programming language နဲ့ရေးသူကဒီ shopping cart shopping user shopping cart microservice ကိုသူကလုပ်တယ် and then product catalog microservice so ဒါမှဒီမှာဆိုရင် product catalog so what is my product here catalog product catalog microservices blue product တွေရှိတယ်ဥပမာ insurance company မှာဆိုလို့ရှိရင် insurance product တွေရှိတယ်taxi company taxi bike company ဆိုလို့ရှိရင်ကျွန်တော် taxi အမျိုးအစားတွေအများကြီးရှိတယ် online so grocery store market solution grocery တွေအများကြီးရှိတယ် right this is called another microservice right product catalog microservices written in different programming language right our currency microservice you have different currency right and it's another microservice anyhow any currency business logic ကို currency microservice ကို Node.js နဲ့ရေးထားတယ်သူရဲ့ business logic ကဘာလဲဆိုရင် converts one money amount to another currency right ဒါသူရဲ့ business logic okay this is here and then you get the idea right shipping microservices email microservices checkout microservices recommendation microservices add blah 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 then your business grow then all of these microservices will start to grow okay this is how the Amazon started right Amazon online shopping the PVNet and then they start to have so many microservices grow and grow right they have thousands of microservices written in different programming language the microservices nature the microservices the programming language the we use on who do that it's a developer job developer write it right using different programming language. So, but the card microservice, the one team, like maybe 4, 5, 6 developers writing this card microservice. Right? That is a right? Maybe product catalog microservice, another team writing that using Go programming languages and the product catalog microservices go to a right? Currency microservice, blah, 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 blah. You got the idea. Okay? Store there, right? So let's say if you look at here called source, this is a different microservices. Microservices code. Let's see if you pick one, let's see add microservices, then you can see here it's written in what programming language called card microservice. So add microservice. Mama solo, right? Let me show you. Called Java. Oh yeah, I should have stated because microservice. Okay, here go Gradle, solution. Then developer write about business logic, right? Okay, right? And then let's say another microservices. Let's say example currency microservice. Currency microservice written in this is written in here. Oh, sorry. Or GS. It is written in code. Let me see. I know. Oh, no GS. Sorry. Yeah, JavaScript. .gs to it what JavaScript may use. SRC. Currency microservice. Okay. Yeah, here. Right. Server.js, client.js. Okay, now to another microservice. Let's say it's a payment microservice. Again, written in JavaScript. Look at recommendation microservice. Python right? You see here called .py, Python right? And then DDR, that business logic, right? That business logic, product catalog, so bucket and that developer's job, and that's it. Done. Right? Developers write code, converting the business logic or convert into code and push the code deal. Then they will push the code in this Git repository. And these are the business logic translated into code using different programming language. ED, Okay. Okay, great. So, and I'll be at the next step. Developers and then anyhow generate a business logic or a microservices then they write it, right? Application say any business logic I code you run you want to run in virtual machine like EC2 or maybe Azure VM or Google Compute Engine. Anyway, virtual machine. I'm a physical server RAM. Or you want to run as a serverless RAM. You want to run as a container RAM. Focus on the Kubernetes it will run as a container. The application we need to package it as a container. The containerization. This is the next step, right? Anyhow, package anyhow, then when we will do it later, and we're gonna skip it. High level right? So container you have to write this called Docker file. Okay? The RAM. The code Docker file package then you came out as a container. Container image right? Image image the business logic and we can run on the Kubernetes. That is the second step, right? This is called container packaging applications. Right? So you see here, every microservice will have the Docker file. The microservice business logic package right there. The technical detail, then we will do it later, right? Then don't worry, we will do it later. So you see the Docker file. Every single microservice will have this Docker file, right? Yeah, okay, this is the second step, containerization. I Docker file, they will store somewhere. Where's the YAML file? The Docker image registry called Docker Hub, for example. ဒီ Docker Hub မှာကျွန်တော်တို့ကဒါ something like a storage place အဲ့ container image တွေကို store လုပ်တဲ့နေရာ and they will store somewhere something like here Docker Hub ရှိရဲ့ AWS မှာဆိုလို့ရှိရင် Docker Hub လို့မျိုးဆိုရင်AWS ECR ဆိုတာရှိရဲ့အတူတူပဲဘာမှမဟုတ် तू ကခုနကကျွန်တော်တို့ဟိုလုပ်လိုက်တဲ့ image တွေကို तू က store လုပ်တာ right ဒီ business logic ကို business logic ကို package လုပ်လို့ရှိရင်ဖွင့်လာတဲ့ image တွေအဲ့ image ကို they will store in something somewhere here right and let's say container registry is a storage place အဲ့ container image တွေကို store လုပ်တာ maybe Google call it Google Container Registry I think sorry GCP yeah Container Registry Azure call it okay call it Azure which shall I AWS ECR equivalent in Azure okay Azure Container Registry am I right အဲ့တော့ကျွန်တော်ကဘာလဲသိစေချင်တာလဲဆိုလို့ရှိရင် cloud provider doesn't matter right ကျွန်တော်ကဒီ concept ကိုသိရမယ် then အဲ့ဒါပြီးတော့မှကျွန်တော်က cloud provider specific technical details ကိုကျွန်တော်ကဆက်လေ့လာရမယ်နော် and they were packaged and they were stored let me find သူ့ရဲ့အဲ့ image တွေကဘယ်မှာ store လုပ်ထားလဲကျွန်တော် I need to find it is it in the scaffold wow then I need to find it 1 second don't slash Kubernetes manifest okay anyway တက်တာမရှိကျွန်တော်နောက်မှကျွန်တော်ရှာပြီးမယ်သူ့ရဲ့ဒီ image store လုပ်ထားတဲ့ဟာတွေ cd demo microservices demo cd microservices demo apply dot release Kubernetes manifest okay dot release Kubernetes manifest there we go found it so အဲ့တော့ तू ကဘယ်မှာ string လုပ်ထားလဲဆိုရင်အဲ့ခုနကျွန်တော်လုပ်လိုက်တဲ့ဒီ APK package လုပ်တဲ့ဒီ Docker image တွေထွက်လာမယ်အဲ့ image တွေကို तू ကဒီနေရာမှာ store လုပ်ထားတယ် they use of course Google ရဲ့ demo ဖြစ်တဲ့ they use a GCR Google Container Registry.io GCR.io something like here GCR Google Container Registry it's just a file label right အဲ့မှာကျွန်တော်တို့က store လုပ်ထားမယ် and then store လုပ်ပြီးအဲ့သူ့ရဲ့ဘယ်အဲ့ store လုပ်တဲ့ဘယ် repository ပါညာပြီးกว่าအဲ့ဒီဟာအဲမှာသူက store လုပ်ထားမယ် right Google sample microservice demo email service right one microservice right and then နောက်ထပ် microservice တစ်ခုကြည့်မယ်ဆိုလို့ရှိရင် then this is another microservice called checkout microservice right တော့ the image thing you see here image ဒါ Docker image ပဲ right container image ခေါ်တာပေါ့နော်အဓိကကျွန်တော်တို့က Kubernetes ရေးတဲ့အခါမှာကျွန်တော်ဘာလုပ်ရမလဲဆိုရင် we have to write this manifest this YAML file right ဒီ YAML file ကိုကျွန်တော်တို့ရေးရမယ်ရေးပြီးလို့ရှိရင်ကျွန်တော်ကအဲ့ microservice ကိုကျွန်တော်တို့ Kubernetes cluster မှာကျွန်တော် deploy လုပ်မှာ okay ရမယ် so that means the next ဒါဆိုရင်ကျွန်တော်တို့ကဒီအဲ့ Docker image ကိုကျွန်တော် package လုပ်ပြီးပါပြီ and then အဲ့မှာကျွန်တော်ဘာလုပ်မလဲဆိုရင်ဒီလိုမျိုးဒီဟာကိုရေးမယ်ဒီ manifest file ကိုရေးရမယ် right okay ကျွန်တော် deploy လုပ်ချင်တဲ့ microservice က email microservices ဆိုရင် then okay write this YAML file email microservices and then deploy on the Kubernetes cluster အဲ့တော့ကျွန်တော် Kubernetes cluster ရှိရ okay this is high level right only 3 steps business logic converts into code I code store in the repository right okay အခုလည်းကျွန်တော် store လုပ်ထားသည် GitHub မှာ store လုပ်ထားတယ် email store in some other repository right အဲ့တော့ကိုကဘာသိရမလဲဆိုရင်GitHub လိုမျိုးတခြားအဲ့လိုမျိုးကို Git repository ကို store လုပ်တဲ့တခြား product တွေပါရှိမလဲကိုကစပြီး ecosystem ကိုနားလည်ရမယ် right GitHub GitLab Bitbucket there are other products out there right it doesn't matter right အဲ့တော့ကျွန်တော်ဘာလို့ဆိုရင်ပထမဆုံး don't focus on GCP AWS EC2 ဘာညာအဲ့ဒါအဲ့ဟာကို focus လုပ်နေ focus on the pattern technology pattern ကိုကျွန်တော်စပြီး focus ကျွန်တော်ပြောရလားမသိ right စဉ်းစားပါ okay developer write code အဲ့ code ကို store လုပ်ဖို့လုပ်မယ်ဘယ်မှာ store လုပ်မလဲ okay repository မှာ store လုပ်မယ် happen to be we ကျွန်တော် store လုပ်တယ် GitHub မှာ store လုပ်တယ် right GitHub owned by Microsoft now okay GitHub ကဘာမှာ GitHub ပဲရှိရလားအဲ့ code ကို store လုပ်ဖို့အတွက် no there are other products out there right let's say then let's look at itကျွန်တော် GitHub equivalent in AWS what do they call AWS call it code commit ဘာလဲဆိုရင် It's a place to store the source code. That's it. And GitHub equivalent in Azure. What do they call it? Call it Azure DevOps. And GitHub equivalent in GCP. GCP call it Cloud Source Repository, CSR. It doesn't matter. Right. See, အဲ့ pattern ကိုကျွန်တော်ကစပြီးတော့ကျွန်တော် training မှာကျွန်တော် I start to train based on the pattern, right? အဲ့ pattern ရပြီဆိုတော့မှ only then how to type the commands, how to configure, right? ကျွန်တော်အမြဲတမ်းနောက်တယ် if you don't know why you're doing, you are keyboard monkey or type the command, right? Why you're typing? No, I have no idea. Just type the command. Happily type, right? Okay. We general we don't want to be that keyboard monkey, right? Okay. And then Daga cloud provider then put the source code repository, something like GitHub. Now I'm more GitHub equivalent, just as like GitHub competitor. So many. GitLab, Bitbucket, there are so many. Okay, does it matter? It's not. So then, what is next then? Source code we compile package and then run as a container, right? Containerization. Container is a general term. Happen to be called Docker is Docker got one of the implementation of container. So that means what Docker equivalency variable. Then yeah, we don't know. Then let's search it, right? And then you can search Rocket container D and blah 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 blah. There are some other out there. They do the same thing. Package the application, came up with the image, and we can run the image in the Kubernetes. Got the idea, right? Then the next step, come to Kubernetes. What are the Kubernetes equivalent? Kubernetes it will do a container, a microservice to run to orchestrate over here, right? So what is the Kubernetes equivalent? There are others like a mesospheres, like Kubernetes equivalent, Docker Swarm, right? Blah 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 blah. I be a Kubernetes competitor, right? But just who is the winner? Kubernetes become the winner in an industry. So okay, which technology you pick up low, pick up low, anyhow, train. Okay. So the next step. Kubernetes then now starting from cohort 3 and then I started at service mesh. You see here called service connect and secure application. Generally, the microservices the team the email so email team own to a business logic and they have another microservice different team, right? You see, the allow the people to user where below IPC yare key general microservice pump and there will be a lot, right? We don't know, right? I go the case master machine, they only have 11 microservices, right? So it will have here and here and here and there, right? Damn it, right? Okay. 80 microservice. So that was kind of the microservice ko communicate with any had the jetting blue kimle. Let me taxi call there, taxi book there, taxi the ma garden with your popular general application. Okay, taxi you call so taxi the bar yamla and you wait for half an hour. So that means there's some problem between different microservices, right? And then okay, taxi go yawla there, and taxi the ma yawla, and then it would need to call finally generate payment or checkout microservice which call me. Rather general percent be hold them. I microservice call me out. Call me out $1, right? General to see any yaw by percent be like count them, right? So you see that these microservices, they need to talk to each other, right? They need to communicate to each other. And then let's say the microservice to another microservices. Because the microservice the different team. They own different team and they own it, right? Oh, the microservice and the microservice security policies. Example, right? Any hago palo call solution. Elumio low go service mesh. Right? here. Connect and secure application, right? Anyhow, we call it application networking. So it's a network engineers connect the boxes, right? Router, switches, and firewall. Now you see everything is about application. The application now started to connect each other. You need to connect. You need to secure, right? Hardware underlying network is already abstracted, right? It's already abstracted. Where's the hardware in the cloud? No, everything's about the business microservices, right? We need to secure, connect application. Now, so to know about it, observability, right? Traditionally, so monitoring board, yeah, right? I mean, it's more than that now. Monitoring and observability is different, right? So observability solution, right? Logging, metrics, and tracing. By the solution, the microservices could communicate low. What is the latency like? It's the networking, right? How many hops, right? Network engineer know how many hops can the microservice comment? How many hops? What is the latency? Example, person taxi the model call it, and then payment of the payment, I'm a B-roll, right? It's loading and loading and loading. There's some issue. There's some latency between these small little microservices, right? Any hard they go look for that, then people start to use called service mesh. I don't know, Kubernetes got 8 machine be like. Kubernetes is orchestrator. The microservice who are run the technology up right? Kubernetes can do all these kind of things, but they can't do all of these fine-grained Kubernetes connectivity, security, and observability. Yeah, that's where the service mesh comes in, right? Then service mesh, their technology, yeah, different implementation, right? So look at this side. Don't at this side, right? So business logic, this is technical implementation, right? This is business logic. Containerization happen with the Docker. It may be Docker, Rocket, right? Orchestration is running the applications, Kubernetes, Mesosphere, Docker Swarm, right? And the service mesh, right? Connecting a secure application is still happen to be one. Then, again, what is the pattern? Service mesh functionality will provide low B9 technology city, the top Istio, Linkerd, Kuma, blah, 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 blah. There are a lot of service technology out there. Right? Yeah, right. So key concept is not Istio. Key concept connect, secure, and observe called service mesh. Service mesh is an umbrella term. Istio, Linkerd, the technology implementation. Yeah, right. If we then you pick one technology, let's say example Istio, right? Then you can pick up easily like Linkerd. Maybe Istio pick up maybe customer, maybe you want to use console or Linkerd or blah 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 blah. Then you can just read the documentation and right? Start to see the technology patterns. Okay. Any questions so far? All right, cool. So no questions means good. All right, the solution, general the solution. This is high level overview, and then we can start to do the hands-on. But we can run microservices with mouth. We have to do hands-on. Okay. So who want to share the screen? Okay. Yeah, it should be rotating, right? It's not the only 1%. It should be rotating. Yeah. Okay, cool. All right. At the demo, Kubernetes, be patient. So now we study. Maybe another 2 months later, and everybody will be aligned. Then we can do all this kind of fancy stuff that you want to do. Oh, sorry. Okay. Who is it? Uncle Ku, right? Yeah. Cool. You can make host. Wait, right? This is a high level, right? It's a high level overview. and DT ရပြီဆိုလို့ရှိရင် then the PV နဲ့ then we will go top down approach ပဲကျွန်တော်တို့သွားမယ်ဟာ okay အဲ့တော့ဒီအခုကျွန်တော်တို့ Kubernetes cluster ကို run တဲ့အခါမှာ right population simulator သုံးတယ် or kind right Kubernetes cluster and tactical ဟိုကတော့ details ကတော့ then ဘယ်လိုမျိုး run နေဘာကြောင့် run နေပါညာအဲ့ဒီဟာဖြည်းဖြည်းချင်းကျွန်တော်တို့သွားမယ်နဲ့အခုလက်ရှိတော့ကျွန်တော်က we will start with high level first so ကျွန်တော်ရဲ့ question ကဘာလဲဆိုရင်ကျွန်တော်တို့စကားလုံးအမြဲတမ်းသုံးတယ် Kubernetes cluster နဲ့သုံးတယ် what is the cluster ဆိုတာပါ what is cluster တွင်းလိုက်အတွင်းလိုက်ဘယ်အတွင်းအတွင်းလောင်းဘာတွင်း so what is a cluster
device တွေအများကြီးကို group မျိုးဖွင့်ထားရအောင်
device တွေအများကြီးကို device တွေအများကြီးကို group မျိုးဖွဲ့ထားတာ okay so another one
စင်တူတဲ့အရာတွေကို group တစ်ခုဖွဲ့ထားတယ်
အဲ့လိုစင်တူတဲ့အရာတွေ group ဖွဲ့ထားတာ okay and then another one
တစ်ခုထပ်ရှိအောင်နော်
တစ်ခုထပ်ပိုရှိတယ် okay
ဖွဲ့စည်းလိုက်ဘယ်လိုဆက်ကြအောင်ဖွဲ့စည်းထား
ဖွဲ့စည်းလိုက်အဲ့လိုလုပ်ဖို့အဆင်ပြေအောင်လုပ်ဖွဲ့စည်းကြတာ okay great in the simple terms ကမှလည်းဆိုရှင် in the Kubernetes context မှာဆိုရင် it's just a collection of computer that's it right you have your computer တနည်းပြောရင် virtual machine or ဒါမှမဟုတ် nodes right or ဒါမှမဟုတ်ရှင် resource right a collection of a resources တွေ computer လေးတွေကနေပြီးတော့ and then you form as a cluster right ကျွန်တော် cluster လို့ just minimize လို့ရှိရင်သိတယ် right cluster ဆိုလို့ရှိရင် that means you will have one cluster ဆိုရင်အဲ့ cluster မှာ compute right compute 3လုံးပါမယ်4လုံးပါမယ် right that is called cluster right? A collection of resources right a resources it may be similar feature or it may not example right ကျွန်တော်ရဲ့ဒီ virtual machine တစ်ခုက maybe memory 16 gig with 1 terabyte and you have another node gig whatever the resource compute resource capacity it may be different right but anyway we don't go that deep right and now ကျွန်တော် deep သွားကြမလို့ definition is collections of computer that's it အဲ့တော့ Kubernetes cluster လို့ပြောလိုက်တာ ਨੇ ဘာလို့မြင်ရမလဲဆိုရင် how many computer involved in one cluster am I right how many computers ဒီပြင် how many nodes right အဲ့တော့ကျွန်တော် computer လို့တော့မပြောတော့ဘူး how many nodes ဆိုပြောမယ်ဒီပြင် nodes ဆိုတာဒီပြင် virtual machine ရမယ် right virtual machine ဆိုတဲ့အတွက်ဘာရှိနေဆိုရင် they will have a hardware and you have a software right of the different operating system right yeah right operating system that means you have a hardware and you have a software which is operating system operating system then you will run all of your Kubernetes software Kubernetes and then ပြီးရင်တော့ခု run တဲ့ business logic တွေကို microservices အနေနဲ့ကျွန်တော်က run မယ်yeah right machine ဘယ်တစ်ခုပါလဲဆိုလို့ရှိရင်ဒီ comment ပထမဆုံး comment kubectl get nodes dash white လို့ရေးလိုက်တာ ਨੇ then you will see how many nodes we found node ဘယ်နှခုရှိလဲ4ခုတော့4ခု right so you see the first node is called kind cluster dash box dash control dash plane အဲ့ပထမဆုံး node ရဲ့နာမည် right တိတ်မြင်အဲ့ virtual machine it may be physical machine ဖြစ်နိုင်တယ် right doesn't matter right it's a node and you have another node called worker 1 2 3 right ဘာလို့ကျွန်တော်အလုပ်ပြလို့ရလဲဆိုရင် look at here called OS image တွေလား this is called Debian Linux 11ဘာညာပြီကွာ right virtual machine one and then you have to have the normal operating system here right and then Linux with that they will have its own kernel version right kernel version ပဲ and then ဒီဟာတွေအကုန်လုံးတစ်ခုနဲ့တစ်ခု communicate လုပ်ဖို့လိုတယ် right ဒီကဘာလို့ဒီအဲ့ virtual machine ဒီကိုယ့်ရဲ့ cluster တစ်ခုနဲ့တစ်ခု communicate လုပ် that's why they need IP address here called 172.18.0.2345 အဲ့ networking perspective ကနေကြည့်မယ်ဆိုလို့ရှိရင်ဒါဒီ first layer of networking ဘာကြောင့်လဲဆိုလို့ရှိရင် you may have 100 nodes. Althoughကိုယ့်ရဲ့ environment မှာ if you have maybe 10,000 microservices how are we going to run right ဒီဟာမလောက်တော့ဒီ node လေးသုံးခုနဲ့မလောက်တော့ then you will ကိုယ့်ရဲ့ cluster size start to grow and grow right ကျွန်တော်ပြောပြစီမြင် there's one layer of networking virtual machine level networking okay yeah man right and then then you maybe have more than one cluster that means example D cluster ကခုနကကျွန်တော်ပြော payment microservice team ကthey want to run their own Kubernetes cluster and you have another Kubernetes, another team, product and service team, let's say, check out microservices. They want to have their own Kubernetes cluster. Right? That means, so you have multiple Kubernetes cluster. Right? Okay. That means if you have 20 different teams, 20 different microservices, they want to have their own authority. You have 20 different Kubernetes cluster. Right? This is what's happening in the business, right? Example, so you have one Kubernetes cluster, about 100 nodes. Okay, you have 100 nodes, right? And all of your microservices, except you are a bank, right? All of your microservices like payment and loan and saving account and shit, bank Kubernetes cluster run hard. What if that Kubernetes cluster down? The whole bank down, right? The Kubernetes cluster, they will start to break it down. Okay, based on maybe business unit, right? Okay, one team, one Kubernetes cluster, or maybe one microservices, one Kubernetes cluster, right? Then they will start to have break it down, right? And now the club might say, oh, I have this one microservices running on AWS, one Kubernetes cluster, but another team, oh, I want to use Azure, right? Okay, there's another Kubernetes cluster. Now the club might scenario, let's say, primary microservices running on AWS, another you have a backup Kubernetes cluster running on Azure. Then if the AWS is down, Kubernetes cluster are fine, right? But the cloud provider is not reliable, right? If the AWS down because of whatever reason, then how are you going to route the traffic to another cluster in Azure, right? Right? Fundamentally, then we decided to know all these kind of things. Then you see fundamental networking layer start from there. Right? You have AWS layer, Kubernetes running on AWS, how to connect the networking to Azure running on your Kubernetes cluster. But I don't know microservice here, eight Kubernetes cluster you want RAM, right? And how are we going to communicate? Is a networking such important? Networking kicking, right? So then, it's not about how these cloud provider communicate below there. Of course, underlying they will use a BGP, OSPF, VXLAN, Geneva, but it's already abstracted, right? It's like cloud provider do okay, okay, direct connect, boom, done, we got it. General focus below Kubernetes, it start from this Kubernetes networking layer. The below. Cloud provider didn't do the cloud provider the low bit. That one layer. And I be the Kubernetes cluster the node general microservices run, right? So every microservice will have its own IP address. Without IP address, cannot communicate. That will be another networking layer. We call it container networking. Then you need to know another kind of chain, right? Another subnet, right? And then because Kubernetes nature, like the microservices get ephemeral, that means like it's born and die, and like it's just short-lived. Anyhow, and then you have another networking layer called service, and you have another networking layer called load balancing, and networking become complicated. In this, it's a whole new game from traditional networking perspective. It's a whole new game, right? Okay. And then beyond then, internet kind of traffic we the ingress that is traditional solution to Cisco ISR router, right? You have the internet router at Cisco ISR, right? The cloud came machine is gone, right? It's called ingress. It's a little small software, and then you have a load balancer. How are we going to route the traffic? How are we going to distribute the traffic? And then traffic the name who work to cloud provider, the cloud provider right? All these kind of things started to happen. And so yeah, like whole new world, exciting, interesting, and you get some idea, right? Who's one direction. And okay. All right. So demand solution and general balance is right? Every column go general right? Every single column, right? Kubectl again white, and you see every column. So general demand solution node here, right? You see here called kind box cluster by one master, 1, 2, 3, and then status got ready, so everything is fine. And my 2 rows, some say control plane, some say none. Why? Each, that means the node city is already up and running for Selena, like 14 hours. Kubernetes version is 127. The algo don't have Kubernetes version is 127. But I don't know if you're I'm look at this to be a kind config, which is to the node 127. Okay, and then to an internal IP is 172.18.0.2345. Okay, and external IP ဆိုတာမရှိဘူး then ကျွန်တော်အဲ့ဒီဟာကိုလည်းနောက်ပိုင်းဖြည့်နေရှင်းပြမယ် and then ပြီးရင်နောက်က operating system image denote the and you have to have an operating system image and then ပြီးရင် of course it's a Linux then you have a kernel image and then ပြီးရင် container runtime okay container runtime ကဒီနေရာမှာ container ကြီးကိုသုံးထားတယ်ဘာကြောင့်လဲဆိုလို့ရှိရင်ကျွန်တော်ရဲ့ခုန ကျွန်တော်ပြောတဲ့ slide ကိုသွားမယ်ဆိုလို့ရှိရင် you will have the business logic convert into code and container run ဖို့အတွက်ဒီ Docker container is a container အဲ့ဒီဟာ run ဖို့အတွက်ကျွန်တော်ကဒီ container runtime software လိုတယ် happen to be ဒီနေရာမှာကျွန်တော်ကသုံးတာ container ကြီးကိုသုံးတယ် right it'sဒီဟာမရှိဘဲနဲ့ကျွန်တော် container microservice ကိုပြောတာအဲ့တော့အခုဆိုရင်ကျွန်တော် terms တွေကိုကျွန်တော်အမျိုးမျိုးခွဲသုံးသွားပြီ container microservices business logic ကျွန်တော်အဲ့လိုပြောဆိုရင် is all the same right yeah okay so ကျွန်တော်ဘာလုပ်လဲဆိုရှင် go to some drawing maybe draw.io or something draw.io go to draw.io let's say decide later okay အခုကျွန်တော်ဘာဆွဲမလဲဆိုရင် we need to draw 4 box right box လေးခုဆွဲမယ် that means ကျွန်တော်ရဲ့ Kubernetes cluster we have 4 nodes right so let's draw 4 box draw the rectangle yeah we have 4 box 1 2 3 4 yeah and the audio horizontal solver ဆွဲလိုက် yeah and ကျွန်တော်အဲ့ box ကကြီးရမယ်ဘာကြောင့်ဆိုရင်အဲ့ထဲမှာကျွန်တော်ကစပြီးတော့စာရေးတော့ right okay အဲ့တော့ကိုကဒီ exercise ကိုကျွန်တော်တို့လူတိုင်းလုပ်ဖို့လိုတယ်ဘာကြောင့်လဲဆိုရှင်ကိုက hands on ဒါမျိုးလုပ်တယ်ဆိုလို့ရှိရင် number 1 you will be ready at the interview example explaining about Kubernetes အဲ့ဆိုရင်ဘာလုပ်လဲဆိုရင် interview မှာ go to the whiteboard draw the white marker pen and you start to draw this and ကိုကစပြီးတော့ you will start to explain like ကျွန်တော်တို့ explain လုပ်တယ်လို့မျိုး right okay I have a Kubernetes cluster how many nodes I have you have these 4 nodes right and then let's give it ပထမဆုံး column ကပါလဲoutput ကိုတွားလိုက် kubectl again node stash white right ပထမဆုံးက like အဲ့ box ရဲ့နာမည်ဒီ kind box class kind cluster box control plane just copy and then paste it right အောက်မှာ paste ဆိုလိုက် as အောင်ကိုအဲ့ဒီဟိုyeah out yeah right ဒါက every node will have a name this is like a host name right yeah okay clear right ကျွန်တော်အဲ့ဟာကို select လုပ်ပြီးမှyeah okay I think so yeah highlight questions okay cool nice okay ဒါဆိုလို့ရှိရင်ဒါကျွန်တော်တို့ရဲ့ Kubernetes cluster ရဲ့ပထမဆုံးnode and then you will do the same for 3 more nodes rightကျွန်တော်ဒီဟာကိုဘာလို့ဒီလိုမျိုးလုပ်ခိုင်းလဲဆိုလို့ရှိရင် I want to ကျွန်တော်အကုန်လုံးဆို whiteboarding skills ရအောင်လို့ right ဒီနေရာမှာကျွန်တော်တို့ကဒီ draw တော့ဟိုဟာကိုသုံးတာပဲဒါပေမဲ့ကိုကဒီလိုမျိုးလုပ်ထားတယ်ဒီလို practice လုပ်ထားတယ်ဆိုလို့ရှိရင် when you go to get an interview ဟို interview မှာတွားတဲ့ခါကျလို့ရှိရင်ကိုက whiteboarding ကိုလုပ်ရဲတယ် the moment ကိုကပါဇက်နဲ့ဒီတိုင်းဖြည့်နေရတဲ့ဆိုလို့ရှိရင် right interview မှာကိုက okay ဟို whiteboard ရှိပြီ marker ရှိတယ်လို့ယူပြီးတခါတန်းပြီးတော့ whiteboarding ဆွဲပြလိုက်လို့ရှိရင် then that's how you influence the interview rooms okay ဘာလို့လဲဆိုရင် like you confidence right ဘာလို့ကျွန်တော်ကဟိုဒီ whiteboarding မလုပ်confident မရှိတဲ့သူက whiteboarding မလုပ်ရဘူး right how you going to draw because you have to draw in person right ကိုက draw လုပ်ရအောင် right အဲ့ဒါကြောင့်မလို့ that's the reason it's all about practice so this is for whiteboarding practice for interview okay and then what is the next right and right but about not called rows control plane and the chart the none so then we gotta put in that information but about how the control plane I control plane is selling highlight and double click sorry ကျွန်တော်ပြအဲ့ဟောင်း delete လုပ်လိုက် delete ပြန်လုပ်လိုက် yeah I kind cluster box ကို double click no I kind cluster box control plane ဆို text လေးကို yeah and then go to the cursor all the way down and enter and paste right yeah okay so the control plane တခြားအဲ့တော့ Kubernetes မှာ like it was split we have the control plane called ကျွန်တော်တို့ကဘယ်လိုခေါ်လဲဆိုရင် master လို့ခေါ်တယ်right and then ကျန်တဲ့ဟာတွေဒီ worker တွေလို့ခေါ်တယ် right so worker ဆိုတော့ဒီအဖြစ်ပါလဲဆိုလို့ရှိရင် like အဲ့ worker ကျွန်တော်တို့ရဲ့ microservices တွေ runs on the most of the time runs on the worker nodes okay အဲ့တော့ master node မှာ run နေတာ run လို့ရတယ် anyway အဲ့ဒီဟာ scheduling affinity anti affinity အဲ့ဒါတွေက now advanced stuff တွေမှာကျွန်တော်ကဆက်သွားမယ် right okay အဲ့ဒါ worker nodes တကယ်ပြောလို့ရှိရင် only two types of nodes master node တကယ်ပြောရင် control plane and you have a worker nodes အဲ့ပေါ်မှာ microservices တွေ run မှာကျွန်တော်တို့ရဲ့ business applications တွေ run မှာ right okay and then of course the computer တွေဖြစ်တယ်အဲ့အတွက် they have to have a CPU memory right အခုတည်းရှိလို့ကျွန်တော်တို့ဟိုမှာ simulator ဖြစ်တဲ့ we don't really have much base ဘယ်လောက် CPU ဘယ်လောက် memory ဒီ node size က memory 60 gig 64 gig 1 terabyte ရှိတဲ့ node လား we will do that later sizing နေ right it's အဲ့ဒါအခုတည်းရှိလို့ဒီမှာအရေးမကြီးသေးဘူးရမယ် right these are the VM these are the computer right okay and then of course we have to have operating system right so let's say they happen to be maybe probably Ubuntu I don't know whatever image right and select image for operating system image right and then yeah paste it unfortunately generally Kubernetes cluster we are not using the window or operating system right most of the time 90 window သုံးတဲ့ဟာရှိလားဆိုတော့ you can run Kubernetes cluster at window ဒါပေမဲ့ကျွန်တော်လက်ရှိလုပ်တဲ့ချိန်ဒီထားမလုပ်ဘူးဒီ window Kubernetes cluster မသုံးဘူး right base this or Linux then you need to load Linux right a little bit okay so that's the solution and then go back that's when ကျွန်တော်တို့ Kubernetes cluster တခုစောင့်မယ်ဆိုတော့ you will start to see ကျွန်တော် like what are the fundamental requirements right ဘယ်ဟာတွေလိုလဲဆိုတော့ကိုယ်ကစပြီးသိလာပြီ and then what is the next kind of version ပါညာအဲ့တော့ OS နဲ့ပါလာတဲ့အတွက်ကျွန်တော်အဲ့ဒါသိစရာမလို right but automatically ကျွန်တော်ဒါကိုတည်ပြီးသား right and then ဘာလို့ဖို့လဲဆိုရင် now you need to have the IP address right so write it down the IP address 452 something 4523 yeah ပထမဆုံး note ချက် IP address 4 yeahအဲ့တော့ကျွန်တော်ဒါမှ networking ကသိဖို့လိုလိုက် right အခုဆိုတော့အဲ့မှာ tech VN or then you guys going to was to the architect solution architect you don't want to do developer anymore this is ဒါဆိုကိုကဒီလိုမျိုး high level ကိုကတဖြည်းသိတယ်ဒါမှကိုက advice ပေးနေတာ right you can say okay we need how many nodes right and what is the operating system you need right what is the IP addresses what is the networking like blah 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 right so that's how we're going to think in like an architect okay all right and of course the networking အရာကျွန်တော် connect လုပ်ထားမယ် right for example okay so ဒီထဲမှာ network engineer တွေပါတယ် let's say ဒီ Kubernetes cluster တွေဒီ nodes တွေဒီကိုက cloud ပေါ်မှာမဟုတ်ဘူးဆိုရှင် if it's on premise right on premise ကိုယ့်ရဲ့ data center မှာဆိုလို့ရှိရင် what do you need the nodes they need to connect to the switch right because I have virtual machine right you need to connect to the switch and then physical networking data like it's running on the on premise right okay cloud provider ပေါ်မှာ solution or then you will need a VPC right and then this Kubernetes cluster nodes it will run on the VPC right so you need to know fundamental of like cloud AWS VPC ဘာညာပြီးတော့ကိုကနည်းနည်းလေးသိဖို့လိုတယ် right okay now anyway ဒီရမယ် right အဲ့တော့ဒီဟာဒီ networking ကကျွန်တော် connected each other အဲ့တော့ကျွန်တော်ဘာလုပ်မလဲဆိုရင် we will draw a line and then draw one line so that means one net layer of networking yeah
let's dive in with them
no ဒီလိုမျိုးဆွဲလိုက်172.18.0.456ရဲ့အောက်မှာ line ဒီလိုမျိုး line ဒီကြောင်ဆွဲလိုက် That's right. Okay. And then တနည်းပြည့်ဒီဟာဒီကျွန်တော်ရဲ့ network layer ပေါ့လေ switch ပေါ့လေသိရမလားဟုတ်ပြီနော် alright is just a one network layer တနည်းပြည့် one subnet so is the one subnet using 172.18.4.5.2.3 is within one subnet right and then ပြီးရတယ် and အဲ့ highly equality they will connect like that right this is one network yeah okay just draw like one line but every node's connected to that so တနည်းပြည့်အဲ့ node တွေဒီ connect online switch so that means all of these nodes are connected in one network right yeah that's right yeah okay DD မျက်စိနဲ့မြင်လားမသိ right အဲ့ဆိုရင်ကျွန်တော်က when you go for interview right how do you understand Kubernetes cluster blah 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 okay then then you will start to draw 4 boxes draw one networking you will start to write or you have a master node and worker nodes you have an operating system you have an IP address you will connect အဲ့ဆိုရင်ကိုကအဲ့လိုပြရတယ် oh okay this guy know what is Kubernetes cluster right it's proven DD ရလားမသိ okay အဲ့တော့ command က just let's go back solution data this is what Kubernetes cluster ဒါ Kubernetes cluster ရဲ့ပုံစံ and then what do we need a container runtime right so we copy that container runtime it called container D171 သူရဲ့ဟိုဟာ right အဲ့တော့မှနောက်မှကျွန်တော်ရှင်းပြမယ် container D Docker and Rocket and blah 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 တခြား container runtime တွေပါရှိရပါကွာတယ်ပါပြီးကွာokay okay အဲ့တော့ရပြီဆိုလို့ရှိရင် then ကျွန်တော် go back to ကျွန်တော်ရဲ့ terminal ပြန်သွား right အဲ့မှာ kubectl get nodes right kubectl ဆိုတဲ့ command is a client is a software tools ကျွန်တော်ရဲ့ Kubernetes cluster ပါ၄လုံးရှိတယ်အဲ့တော့အဲ့ kubectl ကနေပြီးတော့အဲ့ Kubernetes cluster ကိုကျွန်တော်သွားပြီး communicate လှမ်းလုပ်တယ်လှမ်းလုပ်ပြီးတော့ကျွန်တော်တို့က query တန်းလုပ်လိုက်တယ် we request hey how many nodes that we have the cluster then and kubectl get nodes dash y general request right and then it will get response okay we have 4 nodes right okay we have a master and then 3 workers it return back a response yeah okay great so I my dash o white ဆိုတဲ့ဟာမှာထည့်ပေးရလို့ရှိရင် and what's the difference look at it that's it that general information နည်းနည်းပဲပြ right if you want to know more details dash o white right output dash o means output white means give me more okay okay and okay the next step နောက်ထပ်တစ်ခုကကျွန်တော်တို့ဗာသိရမယ်ဆိုလို့ရှိရင် kubectl get namespace right namespace ဆိုတဲ့ concept ကိုကျွန်တော်ပြောမယ် so just like kubectl get ns က namespace no get ပါမယ် right behavior ဒီပါလဲဆိုတော့ကျွန်တော်အရင်သိရမယ်အရင်ပြပြ default အနေနဲ့ဘာတွေပါလဲ default behavior ဘယ်လိုမျိုးလဲကျွန်တော်အဲ့ဒီဟာကိုကျွန်တော်အရင်ဆုံး focus လုပ်ရမယ် right kubectl get namespace Kubernetes cluster မှာကျွန်တော်တို့ကဘာပါလဲဆိုလို့ရှိရင်ဒီ namespace ဆိုတဲ့ concept right အဲ့တော့အဲ့မှာကျွန်တော် namespace တစ်ခုပါလဲဆိုလို့ရှိရင်1 2 3 4 5ဒါခုရှိတယ် default namespace kube node list namespace kube public namespace kube system namespace and local pub storage namespace anyway anyhow actually ဒီခဏဒီ deal တဲ့ right ဒီ hierarchy is all virtual now virtual resource ဒါပေမဲ့ခုနကကျွန်တော်ရဲ့ nodes ရှိမယ်အဲ့ဒါဒီ like a virtual machine အဲ့ဒီ namespace ဒီအဲ့ဒီ virtual machine တွေပေါ်မှာ run နေတာဟုတ်ပြီနော် networking တမားရဲ့အနေနဲ့ကျွန်တော်ကဘယ်လိုမြင်လို့ရလဲဆိုရင် think namespace as a VLAN got it okay virtual LAN like VLAN အဲ့လိုမျိုးအတိအကျမဟုတ်ဘူးเนาะကျွန်တော်ပြောတာမျက်စိနဲ့မြင်အောင်ကျွန်တော်ပြောတာ so example you will have a lot of switches like network engineers right or those people who are understanding system engineers you have networking switches right boxes and I never switch the bomb then how we right what do we start to do we start to define the which is called VLAN right let's say my VLAN 1 not VLAN 1 or VLAN 2 3 4 5 7 and blah 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 အဲ့ထဲမှာ okay ဒီ VLAN ဒီ base department အတွက် right base department အတွက်base ဟာတွေပါတယ်ဆိုကျွန်တော် define လုပ်တာဟုတ်တယ်မလား right okay the same pattern same concept right same analogy အဲ့ပုံစံလေးအတိုင်းပဲကျွန်တော်ဒီမှာဆိုလို့ရှိရင် you will have ကျွန်တော်ရဲ့ Kubernetes cluster have 4 nodes right အဲ့ပုံမှာကျွန်တော် you will have the namespaces right ဒီ namespace ဒီ namespace ဒီဘယ်မှာ run နေတယ်ဆိုလို့ရှိရင် it will run everywhere because it's a virtual right ကျွန်တော်မျက်စိမြင်လားမသိအဲ့တော့ဘယ်လိုဆွဲရမလဲဆိုလို့ရှိရင် if you go to the diagram အဲ့ box လေးကိုချိန်လိုက် right you will have ဒီလို download ဒီလိုမျိုးဆွဲချိန်လိုက် no အပေါ်ချိန်လိုက်ပြောတာ yeah so draw the same okay right ကျွန်တော်ခုဒီမှာဆိုရင် namespace တစ်ခုရှိတယ်ဆိုရင် now 1 2 3 4 5 so draw a namespace it will span across all of the nodes right so you draw another one box span across the nodes yeah no a called overlap one later pull down that's right correct pull down all the way yeah also yeah and then you have 5 namespaces running on the node that's really you get the idea now right you have Kubernetes nodes the Kubernetes cluster and you have you create the namespaces on all of these nodes all of the nodes right this is the fundamental concept networking ရဆိုရင်ဘယ်လိုမြင်လို့ရမလဲဆိုလို့ရှိရင် okay one node is like a think as a one is they you know it's like thing like a switch and then you will have your VLANs running across or something like that okay that's when you know my namespace when you have default namespace cool no least namespace okay default and space namespace so NAMESPACE yeah namespace NSကျွန်တော်ကဒီလိုမျိုး draw လုပ်ပြီးတော့တည့်ရတွေ့နေyeah it's boring no it's not boring you ကိုကအဲ့လိုမျိုး the moment you start to do that လုပ်လို့ရှိရင်ဘာဖြစ်လာလဲဆိုရှင်ကိုကတီးတီးထပ်ထပ်ပြင်လာမယ် and then interview အတွက်အရင်အသုံးဝင်တယ် and then ပြန်တယ် now if you want to explain with maybe like in the room design and architecture discussions ဆိုလို့ရှိရင် then ကိုက confidently you dare to draw လုပ်ပြီးတော့ကိုက explain လုပ်နိုင်တယ် right because that you knowတနည်းအားဖြင့်ပြောရင်ဒါဒီကိုယ့်ရဲ့ communication skills ကို practice လုပ်တာဘာလို့လဲဆိုတော့ you see it right when you see it you have confidence and you can explain and you can communicate right ကျွန်တော်ပြော explain လုပ်ရ step by step အဲ့အတိုင်းတော့ကျွန်တော်က explain လုပ်ပြီးပြော then think that way right okay ဒါကိုဘာလို့ခေါ်လို့ရှိရင် namespace လို့ခေါ်တယ် okay you call NS အတူက NS and then ဟိုဒီအရှိကောက်ဆိုရင် NAMESPACE namespace okay in the real world ကျွန်တော်ကဘယ်လိုလုပ်လဲဆိုရင် example let's say a card microservice ခုနက set တစ်ခုရှိရ right maybe one microservices running on one namespace ဘာကြောင့်လဲဝါပိုင်တာ okay အဲ့တော့ကျွန်တော်က and you will start to create more and more namespaces okay in the real world ကျွန်တော်ကဘာလုပ်လို့ရလဲဆိုလို့ရှိရင် let's say example ကိုက platform engineering team ဆိုလို့ရှိရင် let's say ကိုကဒီ cloud provider infrastructure ကိုပိုင်တယ်ကိုက Kubernetes cluster လည်းကိုပိုင်တယ်ပြီး developers တွေကိုကျွန်တော်ကဘယ်လိုအနေနဲ့ပေးမယ်ဆိုလို့ရှိရင် service အနေနဲ့ပေးမယ် hey namespace as a service right ကျွန်တော်နာမည်ကြောက်တယ် platform as a service infrastructure as a service right software as a service ကြောက်တယ် cloud လေးလာတဲ့ခါကျလို့ရှိရင် right okay now what we're going to do in the real world okay ကျွန်တော်တို့က let's say it's in a bank we're going to provide namespace as a service okay it's a hey developer team let's say it's in a payment team I will provide you payment namespace cluster ကိုပိုင်တယ် then hey developer you can run your microservices on this namespace that's it right and then hey another team account microservices, checkout microservices, email microservice, notification microservice, delivery microservices, driver microservices. Every microservices will have their own namespace. As what you know, VLAN do will be network engineers. Okay, I didn't know then we will start to define that microservices, right? Now, I don't know related that by me now user namespace is a boundary, right? It's a boundary for every team, right? And I be then to know because a boundary loaded we can start to define security policy. Example, hey, this namespace can talk to this namespace. This namespace cannot talk to that namespace. This namespace cannot talk to, cannot blah, 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 blah. Then we start to define, right? I namespace about running a microservice card, let's say example, Segushi. And then the microservice say Seguria, Nagua, another namespace machine, another microservice go, Piolo Yame, Piolo Miao, right? Communicate Yame, communicate Miao. You know, a security policy to know Sabi define low the yai. A about network policy or Kubernetes, right? Net pool or NETP, right? Net pool, right? Traditional environment is like network policy development a little bit, right? Because you are a platform engineer, you own everything, right? Starting from system, operating system, network, Kubernetes cluster, all of the defining security policy, you own everything. It's your responsibility, right? And the network policy define the engineer that absorb machine, and then namespace create the engineer that other machine, right? All the skill become emerged, right? Okay, so then you need to know networking system, security, operating system, a lot, right? Okay, anyway, then you got an idea about the namespace. Okay, ဒီရလားမသိအခုကျွန်တော်ဘာလုပ်မလဲဆိုလို့ရှိရင်ကျွန်တော်တို့ရဲ့ microservice ဘယ်နှခုရှိလဲကျွန်တော်ရဲ့ sample microservice ကိုသွားလိုက် right sorry in the Google yep scroll down how many microservices we have okay front end card service product and by the people okay let's create the 11 namespace okay အဲ့တော့ကျွန်တော်အခု yeah that's correct okay အဲ့တော့ကျွန်တော်ဒီဟာလုပ်တဲ့အခါမှာကျွန်တော် I will show you how right open another terminal open a big terminal right big terminal တစ်ခုဖွင့်လိုက် okay အဲ့ vibrant box ကိုအရင်ဆုံးဝင်လိုက်အောင် right vibrant box ကိုအရင်ဆုံးဝင်လိုက်
ဒီရဲဟိုလေ
ကျွန်တော်ဒီ space မလောက် because ကျွန်တော်ဒီ side by side you have two windows side by side no it's okay အဲ့ဒီဟာမမြင်နေရကျွန်တော်ဒီ terminal တစ်ခုပဲ terminal တစ်ခုတည်း yeah that's correct and then make it two terminals yeah that's right okay go into the vagrant box yeah and then do that another one yeah okay အဲ့တော့ဒါဆိုရင်ကျွန်တော်တို့ရဲ့ဒါ Kubernetes cluster ကိုကျွန်တော် terminal တစ်ခုနဲ့ဝင်လိုက်ပြီအဲ့တော့ပထမဆုံး terminal တစ်ခုမှာဘာလုပ်မလဲဆိုရင် you type the commands called watch watch kubectl space
Watch
kubectl yeah kubectl kubectl get get ဆိုတာ like query လုပ်တာ right ns namespace ရဲ့အတူက ns yeah and okay ဒါဆိုရင်ကိုကဘာလို့ဆိုကိုက you are watching right let's see the Kubernetes namespace က5ခုပဲရှိရ right 1 2 3 4 5 okay now the right hand side ဟိုကနေပြီးတော့ you create a namespace set တစ်ခု right so kubectl create လုပ်တဲ့ command က kubectl create okay get ဆိုတာ is like a query right hey show me give me it's http get right kubectl create what is it? Is it like a put or whatever http a post a put or post that basic http developer say by the theory and put la post la banya okay any how good post create post net to look at underline ma http post request net to put or maybe put get the create yeah okay to know create location resource the namespace so that's why you type called ns and then create location namespace set the machine right then yeah and then go back to that exactly front end card service banya pigwa okay yeah like then what is the output is already comes up called front end namespace is already running for 4 seconds right 7 seconds 8 9 10 11 banya pigwa okay then keep creating that 11 namespace so this one of the exam questions is this one right create a namespace number it's nothing no brainer and yeah that's somewhere or more do it then you practice yeah Okay, so then yeah, it's okay. You got the idea, right? And you know, balloon is an exercise. I know that is boring thing. Do this exercise and it's a practice, right? Kubernetes is simple, easy, simple easy but practice is important, right? Speed. You need to practice typing skills so that you can pass the exam, right? And then you need to your typing skills. You gotta be fast. People do like and go typing same machine, right? So anyhow, so and then go back to your diagram and you start to draw that 11 namespaces. Oh yeah, it's easy, man. Please do it. This is an illusion. The Kubernetes concept, the practice will build you will start to lose. And your brain, you cannot think faster. It will be slow. Trust me. So I can like about bio is a maybe bolong right? Do I bolong can how them let the tools told it, right? Okay, you told it. But the moment you start to practice and let the tools let the tool away, if you play martial arts and even let the tool away the game, they can be your out. Let the tool out do you were tool do the shoulders movement there. Do it at I'm about bolong can do right. So that is the reason practice is important, right? Practice. Okay, so that's low switching exercise for right? That's the thing, right? Okay. The namespace we start to run microservices. Okay, we start to run microservices. So the namespace below microservices running there, GGL. That's the next steps comes in called pods, right? PODS pods, right? Kubernetes smallest unity pods. Okay. Now now that command, the kubectl get PODS pods, right? Okay. So kubectl get pods, PODS pods. Yeah. Okay. And kubectl get pods to no resources found in the default namespace. Namespace could not then namespace pods run a pods microservices, right? The business logic. Business logic container package to right? So that's the kubectl gets population to a default namespace run it to a okay. And I'll don't use alias, but people are gonna confuse. Okay, and not about we can use alias and stuff. And I'll be an default namespace not about kube no list namespace. So let's check kubectl get pods. Right. Get pods. Yep. Okay. Bama namespace material solution then to a default namespace run it to a and okay, the kube no list namespace by high pay pod running it not teacher. As we know, now can parameter that means namespace will okay. The comments here are familiar familiar and mean namespace and then type kube no list.
But and you
generate go back to the diagram. Yeah. So what is an namespace like? Okay, kube no list. Yeah, that. Again, I namespace yeah, and you will see nothing, right? As we okay, default namespace by default machine. Kube no list namespace default machine. Okay, and then go and find another microservice. So another namespace. Now the namespace GGL. Kube public. Yeah. Nothing. Machine. Okay, and then let's go another namespace. Oh, finally found it. We found something, right? Generally, a kube system namespace we have these pods running. Then you have the microservice, right? Kubernetes here, good business logic running, just pure Kubernetes cluster, right? Pure Kubernetes cluster, then you see all of these microservices are running. I divide into a Kubernetes system, the Kubernetes function local to running it. Microservices. It's a Kubernetes resource. This is very important. This system, these kube system names is very important. If we messed up this, then your Kubernetes cluster have messed up, right? Okay. As a solution, then go ahead to run a business logic, the application, it will start to have a problem. Also, the county is a key, is a control plane, of course, right? Damn it, right? So, at demonstration general, how many microservices is running now? You can count, right? Maybe pipe WC, and you will say how many lines. Okay, you can count a little bit of Linux command there. So how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 microservices running on Kubernetes namespace. Got it. I'll go good. I probably divide in this way. No, DD, Alea, divide out that window. The guy got no tune. Then general daily jail. Okay, DD yam, no? As we general, we can go back to the diagram. And general, you will see your Kubernetes namespace should be like wide and big. And general, sabio, the Kubernetes namespace, pay microservices running is what general tell you. So you need to draw 11 box called pod, POD as pods, and then give it a name.
The uses and the tail man.
Exactly. But also, I generate a microservice pod, I Kubernetes namespace team run it out. Damn it, right? It is yalam the econo. Oh, yeah, to say. So Uncle Goya, I draw, bring the all the way to up. I namespace got overlap because default namespace and Kubernetes namespace is a different namespace. So we have to bring separate. Yeah. So now I Kubernetes how do you drag on it? I default up zone drag on it. Yeah. Exactly. And then you can expand that Kubernetes system. Right. Then you will start to draw all of these microservices. Okay. That's the first step. That be me. General theorem about this machine. The microservices take a pay note or run on this what general theorem. By the way, you see we have the nodes, right? And these microservices, these pods, right? A pod is a pay note or run on a general theorem. By the way, a microservice like a small little computer, right? One microservice is a small little computer, yeah. So go back to that terminal. Okay, and type again kubectl get pods dash and kube system, right? The kube system pod name system actually a pod. Clear, CLE clear. Okay, up. Okay, space. No. Yeah, space. Okay, we want to know detail, right? Detail so what do we add? Dash or white, right? So type dash or white. Okay, now you see. As we bare microservices, bare pod the what IP address. Every microservice think like it's a little small computer, right? And generate business logic is running on which node? Yeah, right. As we generate diagram is more structured and clear, right? Okay, and my core DNS, first core DNS port, right? 5 core DNS there, 577 AC, about 5W44N. I port the IP address got allowed 10239 at 04. You see, some of the IP address are 10239, some are 172.18, right? Networking subnet is different. Anyhow, we will go deep detail why the opinion so we have the core DNS 5W44 and the MR running is running on control plane box, right? Okay. And go bare port, bare namespace is running on bare node, right? You have to know this. And then you start to draw that. And then put the IP address. It'll go about say small little port. We have a name for the IP address. Okay, I think that's all for today. Okay. Right. Do that exercise, everyone. And I mentioned all of them. Exercise is your responsibility, right? Practice it. The more you practice and the more you become faster. Go your brain and since and then and the whiteboarding interview right? because now if you are asked what is Kubernetes step you can explain now ကျွန်တော် explain လုပ်သွားပုံစံနဲ့ explain အဲ့တော့ဒီနေ့ပြောသွားတဲ့ဟာကိုကျွန်တော်ချုပ်ကြည့်လို့ရှိရင် concept ကဘယ်လောက်မှမရှိ9မိနစ်ဆိုပြီးတယ် right okay okay အောင်ကိုရကျွန်တော်တို့ရက်လိုက်တော့ and then we can do yourself အကုန်လုံးဒီရမယ်လို့လုပ်တတ်တယ် it's nothing so it's simple and easy အောင်ကိုကျွန်တော် host ချက်တော့ပြန်ပြီးအောင်
okay
ကိုဆိုင်ဟိုတခုလောက်မေးချင်လို့ပါခင်ဗျ
Yep
ဟိုဟာလေကျွန်တော်တို့အဲ့ဒီဟို Kube system ထဲမှာထည့်ရမှာ node ရဲ့နာမည်တွေပဲထည့်ရမှာနော်
no ပထမဆုံး layer ဒီ nodes
ဟုတ်
Kube control plane worker 1 2 3 that's the first layer second layer you have a namespace running right you have a namespace each namespace here you have a lot of pods running right but I pods တွေက Kube system namespace ထဲမှာKube system namespace ကဒါမျိုးချက်ထားလေဒါမျိုးဖြစ်နေရလေ
ဟုတ်ကဲ့
and then you have a pod running on Kube system namespace တိုင်းမှာဘယ် node လဲ you know like you have to have all the intersections is exact right place မှာဖြစ်ရ
ဟုတ်ကဲ့
yeah
ကျေးဇူးပါ
ဟိုခုန namespace ထဲက port တွေကဒီကျွန်တော်တို့ kind cluster create လုပ်တော့create လုပ်ခဲ့တဲ့ port တွေလား default ပါတဲ့ port တွေလား
is a default it's a Kubernetes cluster is a default ပါလားအခုလည်းဆိုကျွန်တော်တို့ဒီထဲမှာဘာ microservice ဆိုတာကျွန်တော်မရသေး Kubernetes ရဲ့ default ပါလာတဲ့ဟာ right okay be patient right and we will go slowly okay ကျွန်တော်ရဲ့ foundation and knowledge ကတဖြည်းဖြည်းနဲ့ step by step ကျွန်တော်တို့ဖြစ်လာပြီဆိုလို့ရှိရင် and maybe like about 10 15 session လောက်လို့ရှိရင် like you will see the beauty of Kubernetes and why Kubernetes ဟိုတဖြည်းဖြည်းနဲ့သိလာလိမ့်မယ် okay I think that's all for today I was recording a stop and I can take questions